Have you ever wished you could disappear? Maybe when you were little, you imagined having a magic cloak like Harry Potter. Or maybe you remember the legend of Perseus, using his mirrored shield to hide from Medusa. For centuries, humans have been fascinated by the idea of invisibility. It exists in our oldest stories and myths. But invisibility isn't just for fairy tales anymore. What was once pure fantasy is becoming reality, thanks to the incredible world of science. Scientists today are using cutting-edge technology to manipulate light itself, making objects disappear before our very eyes. This isn't magic, though it might feel like it. It's the power of human ingenuity and our endless fascination with the impossible. In the past few decades, we've gone from dreaming about invisibility to actually bending light in ways we never thought possible. And as we continue to unlock the secrets of physics and materials science, the future of invisibility is limited only by our imagination. Buckle up, because we're about to dive into the fascinating world where science fiction meets scientific fact. Get ready to explore the evolution of invisibility. To understand how invisibility works, we need to understand how we see. We see objects because light bounces off them and travels to our eyes. Our brains then process that information, creating an image. So, to make something invisible, we need to find a way to stop light from bouncing off it. Seems impossible, right? That's where metamaterials come in. Metamaterials are special materials engineered at the nanoscale, a level so tiny you need a super-powered microscope to even see them. These materials are structured in unique ways that allow them to interact with light in extraordinary ways. Imagine a tiny, intricate maze built for light. Early metamaterials could only bend specific types of light, like microwaves. This was a huge breakthrough, but it wasn't quite invisibility as we know it. Think about it. Making something invisible to microwaves wouldn't help much in hiding it from the human eye. We needed a way to control visible light, the light we see with our eyes. This is where the story of invisibility takes its most exciting turn. Enter the world of quantum mechanics, a realm of science that often feels like magic itself. Quantum mechanics deals with the behavior of matter at the atomic and subatomic levels. It's a world where the rules of classical physics don't always apply, and things can be in multiple states at once. Sounds strange? It is! But it's this strangeness that has unlocked a new era of invisibility. Scientists found ways to design metamaterials that take advantage of quantum phenomena. These new metamaterials can be programmed to manipulate light in incredibly precise ways, like directing it around an object as if it wasn't even there. Imagine a flowing stream of water encountering a rock. The water simply parts and flows around the rock, continuing on its path as if the rock never existed. That's similar to how these advanced metamaterials bend light, rendering objects invisible to the human eye. But it gets even cooler. These metamaterials aren't limited to just visible light. They can be programmed to block other wavelengths too, like infrared and ultraviolet light. This means we can make objects invisible to night vision goggles, heat sensors, and even some medical imaging devices. The possibilities are truly mind-boggling. Remember those early metamaterials that could only bend microwaves? They weren't as useless as you might think. They were actually the predecessors to some incredible technology used today, mainly by the military. Stealth aircraft, for example, use specialized coatings inspired by those early metamaterials to absorb radar waves, making them difficult to detect. But with the advent of quantum-powered metamaterials, the game has changed entirely. Now, we're talking about true invisibility cloaks, materials that can render soldiers practically invisible on the battlefield, not just to radar, but to the naked eye as well. Imagine a world where camouflage netting doesn't just blend in with the surroundings, but actually bends light around the soldiers, making them truly disappear. The applications extend far beyond the military, though. Imagine surgeons being able to see through their own hands during delicate procedures, thanks to specialized glasses that utilize metamaterials. Or imagine buildings designed with these materials, allowing for incredible architectural feats and panoramic views that were once unimaginable. And it's not just about what we can make disappear. Think about what this means for displays. Imagine paper-thin, retractable screens on our phones and tablets that use metamaterials to create incredibly vibrant images seemingly out of thin air. The line between the digital and physical world is blurring, and the future is looking more and more like something out of a science fiction novel. Creating these metamaterials is no simple feat. It requires incredibly precise engineering at the atomic level. This is where quantum computers come into play. Quantum computers are a revolutionary type of computer that can perform calculations far beyond the capabilities of even the most powerful classical computers. Think of it this way. If a classical computer is like a bicycle, a quantum computer is like a spaceship. They both have their uses, but the spaceship can take you to places the bicycle never could. Quantum computers allow scientists to simulate and design metamaterials with incredible complexity and precision, pushing the boundaries of what's possible. They can predict how different arrangements of atoms will interact with light, allowing researchers to fine-tune the properties of metamaterials with incredible accuracy. This has dramatically accelerated the development of invisibility technology, taking us from clunky prototypes to sleek, practical applications in a fraction of the time. And this is just the beginning. As quantum computers continue to evolve, who knows what incredible new forms of invisibility they'll help us unlock. We're on the cusp of a technological revolution, and invisibility is just one of the many exciting frontiers we're exploring. With any powerful technology, it's crucial to consider the ethical implications. Invisibility, while incredibly cool, raises some important questions about privacy, security, and even art. Imagine a world where anyone could become invisible at the flick of a switch. How would we ensure people use this technology responsibly? What about surveillance and law enforcement? The potential for misuse is a very real concern. And then there's the impact on art and creativity. How will invisibility change the way we experience the world around us? Will it spark new forms of art and expression, or create new challenges for artists? These are questions we need to grapple with as invisibility moves from the realm of science fiction to our everyday lives. One thing's for sure, the future of invisibility is full of both incredible promise and potential peril. It's up to us as a society to navigate these complexities and ensure that this revolutionary technology is used for good. The future is in our hands, both seen and